Okay, now we're going to take a look at how the juxtaglomerular apparatus plays a role in releasing renin to affect how it affects the output, urine output, and such. So I'm going to let this video play.
Mechanism is the sensitivity of the
Here's the
macula densa
cells
of the
right here.
juxtaglomerular apparatus
This
to
is
the
the
concentration of
juxtaglomerular
sodium chloride
apparatus
in the filtrate, which is proportional to the rate of filtrate flow in the terminal portion of the ascending loop of Henle. Click the high flow button to see this autoregulate. A higher than normal flow of filtrate resulting from an increased GFR causes the concentration of sodium and chloride ions in the filtrate at the end of the ascending limb of the loop of Henle to increase.
We're going to do the low flow.
Filtrate flow, and therefore low sodium chloride,
it's going to slow down the
vasoconstrictor portion of the ascending loop of Henle is also sensed by the macula densa cells.
And it's going to have these granular cells send out the renin.
This condition is usually the result of low GFR.
I only got that because I watched this.
Pressure.
I literally only got that because I watched these videos.
Initiate two effects. One, they decrease secretion of the vasoconstrictor chemicals. This leads to dilation of the arteriole and so increases blood flow, glomerular hydrostatic pressure, and the GFR. And two, the macula densa cells signal the granular cells of the afferent and efferent arterioles to release renin into the bloodstream. Now click the granular cells of the afferent arteriole to see the effect of renin on the regulation of the GFR.
So that's where the renin comes into play with the juxtaglomerular apparatus. To be quite honest, this was the second video I made, and I was misspeaking in the first one and had to actually redo the video. So, to anybody who believes that these videos don't help, they're wrong. They do help.
In the bloodstream, renin triggers a series of events that increase the level of the hormone angiotensin II. You can see this process in greater detail in the blood pressure regulation topic of the cardiovascular system module. In the kidney, increased angiotensin II causes constriction of the efferent arteriole. This causes the blood flow out of the glomerulus to slow, thus increasing the glomerular hydrostatic pressure and restoring the glomerular filtration rate to normal. Angiotensin II also stimulates the release of the hormone aldosterone. The effects of aldosterone in the kidney will be discussed in the late filtrate processing topic of this module.
So, literally, that was literally the second video that I had to make because I was using information that I tried to read from the book and talk during the other video, and I was misspeaking, saying that renin was going to be released during the high flow, and it wasn't. I was miscalling the cells and everything else, and that was just from the reading. So going into it, making it the second time after watching the video, I actually knew what to say and knew what I was talking about on it. So the videos really helped. You know, I knew where the macula densa cells were. I knew when the renin was going to be released by which cells and what it was going to do and everything else. So that's all I got to say about that. I hope you enjoy.